In this lesson, we will see Spanning Tree Protocol (STP) in Packet Tracer. Spanning Tree Protocol is very important for Layer 2. It provides Layer 2 redundancy and loop prevention. For our example, we will use topology on the screen, and as you can see, we have 4 switches. Firstly, we will connect these 4 switches each other. Here we are using crossover cable because we are connecting switch to switch. After STP process, as you can see, there are green lights and one orange light, and let's see the meaning of these lights. Let's start to check spanning tree information with switch 0. As you can see, our switch 0 is the root switch or a root bridge, and the interfaces are in forwarding state, and their role is designated. Remember, the root bridge, all ports are in designated role always. And let's check the switch 1. As you can see, the Fast Ethernet 01 interface of this switch 1 is in forwarding state, and the role is root because it is going through the root. It is the interface to the root bridge, and the other interface is in designated mode, and it is also forwarding. And switch 2. Again, Fast Ethernet 02 is in forwarding state, and it is the root port, and the other port is designated port. And lastly, the important part is switch 3. As you can see, the root port is here through the root bridge, and the other interface is in a blocking state, so the role is alternate here. STP prevents layer 2 loops by blocking the Fast Ethernet 02 interface of switch 3. Now the Fast Ethernet 01 is a root port, and 02 is the alternate port. When this Fast Ethernet 01 interface become down, then the traffic will go through the Fast Ethernet 02. Let's check this with an example. Let's delete the interface between switch 2 and 3, and then see the role change of Fast Ethernet 02 here. As you can see, the port is in listening mode now. Still listening. Now learning mode. And the role is root. And now forwarding. After getting forwarding, the link is become green here. Now, as you can see, all the links are green because there is no loop risk here. Here I would like to emphasize something. STP has 4 states. First is blocking state, and the second one is listening state, and third is learning, and last is forwarding, and here we saw these 4 modes in this switch also. Let's add the link between switch 2 and switch 3 back. And after this we'll see that this link will be up and in forwarding state, and the previous blocking state will come to Fast Ethernet 02 again. As you can see, the Fast Ethernet 02 of switch 3 is in blocking state and the role is alternate, and the Fast Ethernet 01 is in root role, and the set is learning now, and I think now it's forwarding. Lastly, let's check the other show commands in STP. As you can see, there's active, detail, inconsistent, port, interfaces, summary, and VLAN. We can say here, show spanning tree detail. You can see the detail information here. You can say the spanning tree interface, Fast Ethernet 01. We can say the summary. Lastly, I would like to show something more. And here, as you can see, the default priority value, and with this value, switches are selected as root ID, and the highest is more preferable. And after that, the lowest MAC address is selected. And yes, this is basically a spanning tree protocol. And first we check the root bridge here, and then we saw the ports roles and the states, and lastly we checked the switch trees interfaces, and we saw the blocked interface. After that we delete the interface between switch 2 and switch 3, and then we saw that the Fast Ethernet 02 interface of switch 3 is up and in forwarding. And after adding back the link between the switch 2 and 3, we saw that the link become up, and the previous blocking Fast Ethernet 02 of switch 3 become blocking again.